Hi. What can data tell us about the real world? Previously in the course, we have seen how data are very useful when we want to learn about how the world is organized around predictable patterns. Data can show, for example, how an otherwise seemingly chaotic pool of numbers is organized around behavioral regularities. And we can, by examining data, identify causal relationships between variables. But precisely because data is so eloquent, it is also crucially important that we also consider the limits of what can be learned or what can be said with data. And this is why in this presentation, we're going to reflect on the importance of conveying the limits of what can be learned with data when we present our findings and results. There is a certain tension between two opposing goals of our research. On the one hand, it is natural for any given scientist or practitioner to aim for generality. We want to be able to explore the broadest potential scope of our findings. Do they apply to other contexts? So suppose I do a randomized controlled trial that finds out that insecticide-treated mosquito nets in a rural community in Burkina Faso have been useful to prevent or to diminish the prevalence of malaria. Can I assume that this finding applies to other settings? Maybe I have good reasons to suppose that if it worked in this one community, it can work in, say, a neighboring community as well. But on the other hand, we also need caution. We have to ensure that we do not go too far when conveying what we have learned from a given study. We would otherwise be overgeneralizing. So suppose we do a randomized controlled trial to study teenage pregnancy in a given school district in Washington, D.C., and we do this with a specific program run by social workers. Can I assume that the same program would equally work in every other school? Or can I assume that such program would always work? Well, maybe the results depend on an array of local factors, on the specific skills of the individual educators that have been implementing the project, and so on. This type of tension or dilemma often reflects or has a translation in problems that have to do with science communication. We have to make sure that we do not end up presenting our conclusion in a way that is misleading, either because we overstate or misrepresent the scope of a claim, or because we are ambiguous or vague or confused about where these findings applies. This we see very often in how the media presents the findings of the biomedical sciences or biomedical research. There's this interesting initiative called Just Say in Mice. It's a science communication Twitter account that tries to call attention to this very issue. So we often see in media findings that are reported in a way that misrepresents their immediate relevance to the health of people. Think of this finding that you find in that example displayed there, whereby some neurobiologists have discovered an on-off switch for pain located in the central amygdala. While this might be of immediate interest to people interested in the management of, say, chronic pain, it is important to state that this is a finding that applies for the moment in mice, in the model organisms that have been used in that particular research. Is the problem of overgeneralization found also in other sciences? And to special interest in this course in the social sciences, it definitely happens in the social science as well. There is this very interesting study by Jasmine de Jesus from the University of North Carolina at Greensboro and a group of her co-authors which found that the use of generics was rather ubiquitous in psychological research. By generics, we mean broad claims about a category as a whole without reference to frequencies, probabilities, or statistical distributions. Thus, a generic claim saying people have or people display confirmation bias implies a broader truth in contrast to the people in this study displayed confirmation bias. That is describing the behavior of individuals within a sample. Or most people in this study displayed confirmation bias, describing a particular probability. Like 60% of the individuals in this sample had confirmation bias. Notice that this is different from saying people have confirmation bias, which is a generic claim. Research team that we are showing here, of which DGSUS also was part, studied a sample of over 1,000 articles published in 11 psychology journals over a 2-year period. And they found that nearly 90% of articles included generics in the summary of research results. So an example of this is reporting a finding as Americans overstate social class mobility, for example, rather than stating the same fact with a clear reference to the percentage of the sample that actually does. This would actually convey more accurate information and wouldn't leave room for interpreting that a particular finding applies universally when it does not. To add to this problem, we should also note that a lot of research in the social sciences uses samples that are what some researchers have called weird samples. Weird, understood as an acronym that stands for Western, Educated, Industrialized, Rich, and Democratic Societies, which make up for the bulk of the subject samples that researchers manage regularly. So it is very common that we are presenting our results that we have obtained using weird samples in weird societies or weird settings, and we instead present them as if they applied universally. We therefore want to be reminded to be careful about this type of overgeneralization. And this is it for this video. To conclude, we just want to wrap up by saying that we have tried to see how it is important to convey results in a way that does not lead to overstating the scope of our findings in order to avoid confused interpretations on the part of the public. But as we will see in the next video, beyond this issue of communication that we have dealt with, finding out the exact scope of our findings is actually a tricky matter. And so even when scientists are trying to do their best and trying to portray in a very accurate way to the exact scope of their findings, this is a problematic, or this is a difficult task. This we'll see in the next video. Thank you.